All right, this is going to be our next section. It's going to be the first one for transformations, okay? So in particularly, this is 7.1, and it's going to be talking about just introducing what transformations are and mainly focusing on symmetry, okay? So what is a transformation? You did a little bit of this in middle school. This is when a geometric figure, or really any figure, changes in position, shape, or size. So your basic transformations that we're going to cover are when a figure flips, okay? So in this case right here, this one is flipping over here, or when the figure slides, so this one slid to the right and then up. And then, or if a figure turns or rotates, so this one turned over here, or vice versa, this one turned this way about this point. And then this one here, this one changed in size. So this one got bigger or got smaller, either one. And so we saw a little bit of that when we talked about similar figures. And those are your 4 basic transformations. A new vocabulary word in isometry. This is going to be a rigid transformation. And basically all that means is that this transformation is not going to change in size. So they're going to be congruent. So it's a transformation in which the pre-image and the image are congruent. Okay. So out of those 4 basic transformations, I did a few of them here. And so which figures appear to be in isometry? Okay, so remember, an isometry is when your transformation takes place, but both the pre-image and image are congruent. So this first one obviously got bigger from the pre-image to the image. So these are not congruent. They're similar, but they're not congruent. So this is not an isometry, okay? So this one is, I'm just going to put an X through it, not an isometry. Over here, it looks like this is a rotation or a reflection where it flips over this line right here. Okay, or again, it could be a translation. And it looked pretty identical. So this right here, this one is an isometry. Over here, this one clearly is being flipped over this direction. So if it's flipping, it looked pretty close in size. So we're going to say this appears to be congruent figures. So this would be an isometry. And then over here, it looks like it could be, but this one looks like it's stretched out left and right. So this one changed in shape, okay? So it's still a pentagon, but it's not the same one. So it kind of stretched out. So this is not an isometry because they're not congruent. And that's all what an isometry is. So the main thing we're going to talk about is symmetry, okay? So what is symmetry? Our first type of symmetry we're going to talk about is reflectional symmetry. This is where a figure can be reflected over a line in such a way that the resulting image coincides with the original, okay? When that happens, then you're going to see a line of reflection, which is mentioned right here, okay? And so what makes up this line of reflection? All the midpoints of the segments joining a point of the original figure with its image, okay? And that's going to be your line of symmetry. So an easy way to look at this one is this last picture right here. So you can say this is the original and say this is the new one. Well, that would be a midpoint of that entire segment. Same thing here, that would be a midpoint, that would be a midpoint. So all these midpoints on here, okay, will make up the line of reflection, okay? So that is an example of a line of reflection. Or you can see another term there, a line of symmetry, okay? So here are a bunch of examples too of lines of reflection. So this one right here, that dotted line, that is a line of reflection because everything on this side matches everything on that side. And speaking of like the midpoint right here, so if I pick this point A and this new point A prime, well, this would be the midpoint of those two, between those two if we were to make that an entire segment. Okay, so this is a line of symmetry or a line of reflection because the left looks like the right. Here's another example right here. So I'm going to give you a picture of this on your homework, but I'm not going to draw the dotted lines for you. You're going to have to figure out if there is any. Okay, so here's another example because this left looks like the right. And then on this one, there's a lot of lines of reflection. Okay, so here's one right here because this left side would look like the right. All of these are lines of symmetry, every single one. Okay, because if you fold this in half, it would reflect exactly the same way over the line. So this one has how many? 1, 2, 3, 4. 1, 2, 3, 4, 6. So this one has 6 lines of symmetry. Okay, so you're going to have to determine how many there are in some given figures on your homework. All right, and that's line of symmetry or reflectional symmetry. And then the last type of symmetry is called rotational symmetry. So this is when a figure can be rotated about a point in such a way that its rotated image coincides with the original figure before turning a full 360 degrees. I forgot the little degrees. Okay, so 360. So if you look at this figure here, this is a unique figure. This definitely has rotational symmetry. Now these dotted lines I already drew, but you're going to have to be able to draw them on your own. Okay, and so when you look at this figure, let's just say this is the 0 mark right here. Okay, can you rotate this right here to where it coincides again? Okay, and you're probably saying, yeah, to right here. No, because if I rotate it right here, you kind of want to look at the figure. This is a smaller, I don't know, star, whatever this is. And that one is smaller. So if I go rotate to there, that does not coincide. So that would be incorrect. However, if I rotate it all the way to here, then it would coincide again, see, because that one is small, and so it would appear as though when I rotate it to this, it's going to appear like it was from the very beginning. So this coincides. So this has rotational symmetry of this many degrees. We'll figure that out in a second. Can you rotate it some more? Yes, you can go from here or from here all the way to not this line, but this one. So you can rotate it another certain amount of degrees. So you're basically looking like if you want this to be your starting point. Now you can start wherever. This, I just chose to start here. But then again, I can still keep going. I can rotate to there because there's that small one. And then I can also rotate again to there. And then if I rotate one more time, that's going to take me back to a full 360. So that one doesn't really count. So the question is how many rotational symmetries are there? There's 1, 2, 3, 4. There's 4 rotational symmetries. And the way you identify them is by degrees. So you know that it's a full 360. So you want to ask yourself, well, what is each little section? So 1, 2, 3, 4, 5 sections. So what is 360 divided by 5? I do not have my calculator. So let's see, 7, 35, 72 degrees. Okay, so like this is 72 degrees. And then another 72, or you can say from here all the way, if it rotates 144, that would be the second one, and then the third, and then the fourth. So every 72 degrees. So it would be 144, and then add another 72 to 144. So let's see, what we would write down, we would write 72 degrees, then 144 degrees, and then what is 72 plus 144? 216. which takes me to this point. And then add one more 72. What's 216 plus 72? 8, 8, 2, 288. Okay, so the 4 rotational symmetries for this particular unique figure is 4 of them, and the first one's at 72 degrees, 144, 216, and 288. All right, and that's rotational symmetry. So I'm going to give you some figures, and I'm going to ask you to identify how many rotational symmetries there are. All right, that is it. This is a short, quick lesson.